In this video, we'll go over the homework that follows the lecture 15.1 that focuses on solving the arc length problem. And as always, I hope that you watched the lecture, and let's go ahead and jump right into the homework. And in the first problem, we are asked to, for a given function, to find the arc length of a piece of the graph over the given interval. So the interval is from 1 to 2, and we are going to use this formula. So the arc length is equal to the integral on some domain of integration of 1 ds. This is the universal formula that one needs to remember. However, in this particular case, we are going to interpret ds as the square root of 1 plus f prime of x squared dx, and we're going to be integrating with respect to x, so the limits of integration are from a to b, and we're going to set up this problem in 3 steps. First, we're going to find the derivative of the function. It's going to be 2 times, and we're going to use the power rule, 3/2 times x to the power 3/2 minus 1. So it's simply going to be equal to 3x to the power 1/2. Next, we're going to plug everything into the integrand, or the formula that represents the integrand. So this whole thing will be equal to the square root of 1 plus, and here we have 3x to the power 1/2 squared. And the purpose of this step is to kind of simplify the integrand as much as possible, so we don't have to do it and do on top of that the integral. So we're going to separate the algebra and the calculus tasks, and here we get 1 plus 9x, and that's pretty much it. And finally, we're now ready to find L. L is going to be the integral from 1 to 2 of square root of 1 plus 9x dx. And at this point, we can totally ignore where this problem came from and just focus on finding this integral. We're going to set up substitution. And the substitution here will be what's inside of the integral. So dt will be 9 dx, meaning dx will be 1/9 of dt. And because this is a definite integral, we may also change the limits of integration, although it's not necessary, but it's an option that you have to consider. X ranges from 1 to 2, and for the new variable t being 1 plus 9x, to find t when x equals 1, we plug in 1 into this formula right here. And 1 plus 9 times 1 is 10, and 1 plus 9 times 2 is 19. And now we have an integral from 10 to 19 of square root of t dt, but we also have the 1/9, which I would like to write outside of the integral. So we are ready. What will help us is to, instead of the radical, write power 1/2. So we definitely have a simple application of a power rule for integrals, and it's going to be 2/3 t to the power 3/2 from 10 to 19. So simplifying, and we get 2 over 27, and here we have 19 to the power 3/2 minus 10 to the power 3/2. and we are asked to enter the exact answer. So we're going to enter this exact expression, and 2 over 27, we have 19 to the power 3 halves minus 10 to the power 3 halves, and that should be it. And let's go to problem number 2. In this case, we are asked to just set up an integral. We don't have to solve anything, but to practice the skill, I'm just going to kind of follow the same steps as before. And again, once again, remind you that the formula that we're using is this. But in this particular case, we interpret the domain of integration with respect to x, because we also interpreting ds as 1 plus derivative of f squared and the square root with dx. So in this case, we're going to first find the derivative of f, which is 2x minus 1, and we're going to set up this integral as the square root of 1 plus 2x minus 1 squared. I guess I should be more explicit here. So this is our attempt of computing the integral provided this formula. And the final step will be to set up the integral, although we are not asked to find it. That will be the integral representing this arc length. So the lower bound is 2, the upper bound is 7, and the integrand has the square root of 1 plus 2x minus 1 squared. Now, if I had to integrate it, I would probably not sure what I would have done. I would have done the sum substitution here, maybe even trig substitution, but again, that's not the purpose of this exercise, so let's move on. Now we are asked to switch the direction, so we are given a function g of y. So let me write it carefully here. So we have g of y being equal to 3 minus 3y, and the domain of integration is given with respect to y, I would assume, and again, we're looking for the arc length, for which the universal formula is this, but because we are given everything in terms of y, we're going to interpret ds as the square root of 1 plus g prime of y squared with dy by its side, and the domain of integration now will be with respect to y, so it will be from let's say from C to D. So this is the formula that we are going to use, and we're going to do it in 3 steps. First, we're going to find the derivative, which is -3. Second, we're going to plug everything into this formula and find the integrand in its most simplified form. So we're going to have 1 plus -3 squared, so it's just a square root of 10. And finally, we're going to set up the integral. So it's going to be the integral from 3 to 5 of square root of 10 dy. And finding this integral is actually pretty straightforward because it's just the identity function times the square root of radical 10. And the final answer is 2 square root of 10. So we have to enter the exact answer. So I'm going to enter 2 square root of 10. Based on how slow the mastery bar is moving, I have a feeling that it's going to be a fun homework. And the more homework, the better, is the rule of thumb. So in this case, the task is kind of confusing. The domain is given to us in terms of x, but they're asking, for some reason they throw in this x equals g of y thing in there. So let's do it the most intuitive way first, and then I'll address what I think they mean by asking to consider the graph of x equals g of y. So if we're going to consider everything the way it's provided to us, then we're going to be using this formula, and we're going to interpret everything in terms of x. And the first step is to find the derivative of f. And the second step is to set up the integrand in the most simplest way. We have square root of 1 plus 1/4 squared. So it's going to be square root of 17 over 16. So it's square root of 17 over 4. And then the integral will be the square root from 2 to 6 of square root of 17 over 4 dx, which is very simple. And you can see how 4's cancel, and all we have is square root of 17. Now, what do they mean by calculate the arc length of the graph of x equals g of y? Well, what they mean is that sometimes a function can be considered as an implicit function, and then we can pretty much rewrite it any way we want. So in this case, if we want to isolate x, then we're going to have this equation. So it's going to be pretty much we're finding the inverse function. However, this should be y here, not x. And the way I got this is by, I'll write this over here, is from manipulating this equation and isolating x. So we can do that by adding 2 to both sides and then multiplying both sides by 4. And then you can see how x becomes 4 times y plus 2. Now we also need to plug in 2 and 6 to find the corresponding y values. So if you plug in 2 into the equation, then we get 3/2, actually negative 3/2. And if we plug in 6 into the equation, then we get negative 1/2. So I don't really see how this would be beneficial at all, but can we do it? Yes. We can turn the original function into the function in terms of y. Then we're going to consider this universal formula, but now because we turned everything into y related expressions, we would interpret this formula as the integral of 1 plus g prime of y squared dy, and the interval of integration will be from c to d, where c and d refer to the lowest and highest y values. Now we would do this problem by finding the derivative of g, which will be 4, and then we would find this, which will be the square root of 17, and then we would do the integral. It's going to be the integral from -3/2 to -1/2 of square root of 17 dy, and it's going to be square root of 17 times y, -1/2, -3/2, and it's going to be square root of 17 -1/2 minus -3/2, which is just 1. So the integral is also square root of 17, which is the same answer as we got before. So some problems can be done in both ways, and maybe they meant that. I'm not sure what they meant. I'm going to pause and actually report this as a typo in the question. Before we move on, we need to check whether the answer is correct. So let's go ahead and input the square root of 17 here. But we were able to find it in two different ways. So we're pretty sure the answer is correct. Looking at this, I do see that they did it the second way, right? Which, as we can see now, wasn't really necessary. So let's move on to number 5. We have f of x. That progress bar really scares me. Why is it so slow? We have formula, this universal formula, but we're going to be interpreting it as the integral from a to b, where a and b represents the limits in terms of x, and we have the first derivative squared plus 1, then square root, and we're going to do it in 3 steps. First, we're going to find the derivative. It's going to be 3x squared over 6 plus 0 minus 1 over 2x squared. So let's simplify this. And this is how I'm going to simplify it. And next, I'm going to compute this radicand, or rather, not compute it, but find it in its simplest form. And we're going to have 1 plus, and we have f prime squared. So there's a square here. Now I'm going to use nothing but algebra to square this expression. So it's going to be 1/4 x to the power 4 plus 2 times 1/2 x squared times 1/2 x to the -2 plus 1/4 x to the -4. If you wonder how I got this, I just used this formula. A plus b squared is equal to a squared plus 2 times the product plus b squared. This is the formula that I used. Let me put it here as a reference. Where do I put it? Right here. I guess I can put it as a thought bubble. And now this simplifies. This is gone. It's just 1. We have 2 times 1/2 is 1. And I have actually made a mistake here. When there is a minus here, there is a minus here. So this should be minus. So we have 1 plus 1/4 x to the 4. And here's what I want you to notice. Like, this whole thing is equal to -1/2. But if you add it together with this one, you get exactly the same thing, but with a positive 1/2. So algebraically, this, what we have, and what I'm about to write are equivalent expressions, or the same functions. So I can totally just write this and kind of unpack that back into this format. But this is literally the same formula that we had, except with the opposite sign. So it's literally going to be equal to 1/2 x squared, but plus 1/2 x to the power -2 squared. Now, as you know, the square root and the square not necessarily cancel one another, but create this, create the absolute value. However, since all the x's are positive, there is no really need in this absolute value. So this is what we get as our integrand. So to find the arc length, we're going to set up the integral from 1 to 4 of this function. And now, it doesn't matter where this integral comes from, it's just a problem, calculus problem, nonetheless, but a simple one. So antiderivative will be 1/2 times 1/3 x cubed minus 1/2 x to the power -1. And we're going to evaluate it from 1 to 4. Here we just have to be careful. We have 1/6 4 cubed minus 1/2 4 to the power -1 minus, and now we plug in 1. I'll just have to compute this. So we have 4 cubed is 64 divided by 6, so 64 it's 32 thirds minus 1/8 minus 1/6 plus 1/2. And I'm not really into doing all this common denominator, so I'm just going to use decimals here. So 32 divided by 3 minus 1/8 minus 1/6 plus 1/2 is that. We can write it as a fraction, so it's just 87/8 is the answer. And it says enter the exact answer, so we're going to enter it as 87/8. And that's right. This was number 5. We have f of x equals 5x squared on 1/5. And it says use a calculator, so that's good. That means we don't have to integrate it by hand, but we still have to set it up. So to set it up, we're going to use this universal formula. Because of how the problem is given, we're going to be setting it up like this. That is, we're going to interpret ds this way. And we're going to set it up in 3 steps. So the first step is we're going to find the derivative. It is 10x. Then we're going to find the integrand. It's going to be this. And we're going to set up the integral for the arc length as the integral from 1 to 5 of the square root of 100x squared dx. And to find it by hand, we may actually have to do like some trig substitution, but we once again not asked to do this one by hand. We can just use technology. So I'm going to integrate from, I'm going to use Desmos and integrate this function from 1 to 5. And that's the answer. So I used Desmos, and the answer is 120.08, and we have to round to 4 decimals, so 0.412, and we're gonna write the answer is 120.0804. All right. Next problem. We have we're going to use the same formula. I was just thinking whether I should just use technology here since we opened the gate already. But regardless of whether you are allowed or not, here's how you set it up. And we're going to do it in 2 steps. The first is to find the derivative. The second one is to compute this expression. Then we're going to set up this integral. And it's nothing but just a linear function. So the answer is 4 square root of 5. We probably wouldn't be able to get that answer from Desmos, but that's what Wolfram Alpha is for. All right, 7, 8. We have the function given to us in terms of y. So the limits of integration are in terms of y. So we're going to still use the same universal formula, but we're going to interpret everything in terms of y. And we're going to set it up in 3 steps. First, we're going to find the derivative. Then we're going to find the integrand. And we're going to set up the integral from 2 to 6 of 1 plus 4y squared dy. Luckily, we are allowed to use the integrator. Well, I guess you can call it integrator calculator. So integral from 2 to 6 of 1 plus 4y squared dy. Desmos is really good at reading different variables x and y, so let's take advantage of that. And we have to round to 4 decimal places, so we get 32.2729. Oh, we got it. Not sure what with the absolute value. What's going on here with the absolute value? Here, everything is positive, so there is no confusion. whether it's whether it could be negative or not. So I don't think absolute value is necessary there. We have another problem exploiting this well-known pattern in problems like this. So let me show you. And there's nothing special about this. It's just if you follow the steps, you will get through it, whether you know that pattern or not. But again, the formula that we're using is this universal formula for the arc length, which we interpret as the integral from c to d of 1 plus g prime of y squared dy, and g of y prime is y cube over 2 minus, here we have 1 over 2y cube, and we're going to let me show you like a slightly different way of writing this, and again, it only makes sense to write it this way when you take advantage of this pattern. So we're gonna square the g prime, so we get y cube over 2 minus 1 over 2y cube squared. So I'm gonna use this formula here. A plus b squared is equal to a squared plus 2ab plus b squared. And when there's a minus here, there's a minus there. And we're gonna square it, so we're gonna end up with y to the power 6 over 4 minus 2 times y cube over 2. I need to compress this, otherwise I'm not gonna fit everything. Times 1 over 2y cube plus 1 over 4y to the 6. And what you notice here is that this y cube is cancelled, this y cube cancelled, so these two cancel. So all we have is here is negative 1/2. And here's the trick. When you add 1 to the g prime of y squared, you are literally just basically taking this expression, and because it's entirely, like this whole thing in the middle is equal to negative 1/2, so by adding 1, you're turning negative 1/2 into positive 1/2. So visually, the only thing that happens here is the minus becomes plus. But when you change minus into plus, here's what happens in the middle. Your formula now is still true, because the only difference in that formula is whether you have a plus or minus. So the formula is still true, but now you have the plus sign over here, which means that the square root of 1 plus g prime of y squared is literally equal to the square root of y cube over 2 plus 1 over 2y cube squared. And the square root and the square, when removed, produce this expression, the same expression but with the absolute value. However, since y is said to be positive, we don't really need this absolute values there. And that's our integrand. So we're gonna set up the arc length as the integral from 2 to 3, I believe, of y cube over 2 plus 1 over 2 y cube dy. And it's rather a very simple integral, which requires nothing but the power rule. So we're going to have y to the power 4 over 8. And here we're going to have negative. We're going to have 1 over 4y squared. And usually it looks a lot like the original function, so that's kind of how you can check whether you're on the right track or not. And looks like we are, and we have to evaluate it between 2 and 3. We are asked to enter the exact answer, so we have to do all the math here. Throwing in 3 gives us this. Throwing in 2 gives us this. Now it's all your arithmetic skills here. 3 to the power 4 is 81. Minus 1 over 9 times 4 is 36. Minus 2 to the power 4 is 16. 16 over 8 is 2. And here we have 1 over 16. As always, when I'm not into doing all the busy work with finding the common denominator, just throw it in from alpha or Desmos. I already had Desmos open, so let me just throw it in here. And let's write it as a fraction. That's a pretty ugly fraction that could have drained a lot of my time. Hopefully it's the right answer, because I'm certainly not into redoing this problem. So let's see if it worked. Yay, it worked. So let's move on. This is problem number 10, which was a really good collection of problems. As we are approaching the end, we have g of y is equal to 4y squared plus 3y minus 3 on the interval from 2 to 6. We are asked to compute the arc length. We're going to be using this universal formula, which in this particular case we interpret as the integral from c to d, where c and d refers to the limits of integration with respect to y, and we're going to use the following interpretation of ds because of how the problem is given to us. We're gonna set up this integral in 3 steps. First, find the derivative of g, which is 8y plus 3. Then we're gonna find the integrand using this formula. It's 1 plus 8y plus 3 squared. And now we're gonna set up the integral. It's gonna be the integral from 2 to 6 of 1 plus, and I don't really need to square this. This is going to be the setup, and we're not even asked to compute this or anything, so let's go ahead and enter it. 6 2 square root of 1 plus 8y plus 3 squared. And we got it. So we worked towards the end, and now seems like we reached the end of this homework. If you have any questions, feel free to reach out.